Scientific measurement. In this video, we're going to talk about significant figures and the types of measurements that we take. The types of measurement are going to be quantitative and qualitative. So quantitative is a quantity or an amount. It has numbers and a unit. Qualitative is just a description. So if I were to give some examples, like 4 feet, that's quantitative because it has a number with it. Extra large, qualitative. Hot, qualitative. 100 degrees Fahrenheit, quantitative. Scientists mainly prefer quantitative because it's easy to check, it's easy for us all to agree upon. It's a set scale, so we're not as concerned with how subjective it is. So when we look at our measurements and we want to know how good they are, you hear us talk about two things. We talk about accuracy and precision. The difference between the two is if you're accurate, then you are correct. It's right on what the answer is supposed to be. Precision means that you're getting the same thing over and over and over, even if you're not accurate. Okay, so if we think about golf, you can hit the ball in different ways. One, we can hit the ball, and if we continuously hit in the same place, but not where we're supposed to be, then we are
inconceivable.
Not accurate, but we are precise.
Yes.
So then we could hit the ball and we go right where we're supposed to be or where we're hoping to be.
Yes.
So we are accurate, and since we were able to duplicate it,
yes,
then we are also precise. Are we precise? No, we're not. Are we accurate?
Alrighty then.
We don't know. It could possibly be accurate. You may have been aiming for that, to get that close to the green, or you could have been inaccurate. You could have every single time been shooting for a hole-in-one, but yet we didn't get there.
Yes. Have we learned our lesson?
So if a golfer hits the ball and it lands on the green and rolls into the cup, then it was accurate. We did exactly what we wanted to do. But we cannot say if we're precise or not, because to be precise, you have to be able to duplicate that or, repeat it several times. Significant figures. So we're talking about in the digits of a number, which ones are significant and which ones are not. So meaning, how does it help us know how precise our instruments that we're using are? So whatever instrument you're using, you look at the end and then you estimate one place past what's given. So I can definitely see the 4. So I know the 4 is there. So that is significant and that's part of my number. But I am going to estimate how far past the 4 it is and how close to the 5 it is. So I would estimate this at 4.5. If I look at this instrument now, and it has more markings, it is calibrated more. So now I can look at this and I know that it's 4.5 definitely. How do I know? Because the lines are there. Now I'm going to estimate how far past that 5th mark before that 6th one does it come. So I know it's 4.5, and then how close is it? Is it right on the 5? Is it a little past it? Is it almost on the 6? Where is it? When I estimate and look at this, I'm going to say this is 4.55. So if I look at this, then I know that 142.1, we're definitely there. That 5 is my estimation of how close my object ended past that 10th mark. So all numbers are significant. It's significant to know how close I am to that line. Now here, I only have 3 digits that are significant because there's nothing past it. So I know that that 2 was estimated. So for this, it means that my instrument was marked off in the 10th position, but then I estimated that it was at, just 2, just barely past the 140 mark. Whenever I have a 0 depends. There's going to be rules that help us decide when a 0 counts and when it does not. All other digits, so 1 through 9, any digit other than 0 is always going to count. The zeros that are going to count are the ones that come, the ones that are not going to count are the ones that are before a decimal point. So if I have 420, then there's no decimal point in that number. So that 0 is not significant. Again, I have estimated that 0, just like on our example of 142. So here's another example. There's no decimal point here. So these are not significant. These are estimated digits. Any 0 that comes before the non-zero digits and a number, so it's smaller than 1, is not going to be significant. It's just simply holding a place. So if I look at, like our example was 0.045, none of those zeros are going to count because it's just telling us how far we had to get down until we actually were able to start using our measurement. The ones that do count, here I have 2 zeros that are between non-zero digits. Both of these count. If it's at the end of a number and there is a decimal point in it, then those are going to count. So here, this number, 45.8300, has 6 significant figures. So the measured digits and our estimated digit will count as far as significant figures. When we look at numbers like you use in math class that are just a number, if it's something that I'm counting, then it's exact. You could you either have it or you don't. I have 8 apples, then there's 8. We're not looking for how precise our instrument is. We're just saying how many are there. So this number has 458 grams, has 3 significant figures. 4,085 grams has 4 significant figures. 4,850 grams has 3 significant figures. 0.0485 grams has 3 significant figures. 0.004085 has 4 significant figures. And 40.004085 has 8 significant figures. Four 405.0 grams has 4 significant figures. 4,050 only has 3 significant figures because there is no decimal point. 0.450 that has 3. The 0 at the end is significant because there is a decimal point in the number. The 0 at the beginning does not count. Zeros in front of non-zero digits never count. 4,050.05 has 6 significant figures. 0.050060. The only zeros that do not count are the ones that come before the digit 5. So from the 5 on, we count. So there are 6 significant figures. Now we're going to look at significant figures whenever we're doing mathematical calculations. So if I have the number 50, which has 1 significant figure, and I need to show it as 2, then I can use scientific notation and show it as 5.0 times 10 to the first. Now that 0 will count because of the decimal point. Whenever you're adding or subtracting, you're going to look at the number of places past the decimal point, and the number that has the fewest places past the decimal point, that's how many you're going to use in your answer. So if I have 27.93 plus 6.4, if I'm adding the two numbers, then I'm going to look for which one has the fewest decimal places, which is 6.4, and that tells me how many places past the decimal point my answer can be. Remember, it can only be as good as my least estimated number. So if I look at this, I can only go 1 place past the decimal point with my answer. So I line them up, I add them together, and then I'm only going to count, remember, the one that has the fewest places. So 6.4 only has 1, so then I'm going to follow my rounding rules and end up with 34.3. That is what my answer will be. Rounding rules are just normal rounding rules. So you look at the number just past the one that you're going to round, and if it's 0 to 4, don't change it. If it's 5 or higher, then go ahead and round it up. So if I'm going to round this to 4 significant figures, if I count them, 45.462, the first 4 significant digits are 4546. So I want to round the 6. I look at the number past it, which is the 2, and I see that it's below 5, so I'm just going to drop it off. Multiplication and division. For this, you just have to remember that you want to look at the numbers that are being multiplied or divided, and whichever number has the fewest significant figures, that's how many your answer is going to have. So here I have 3.6 times 653. 3.6 has 2 significant figures. 653 has 3 significant figures. I go with the number that has the fewest, 3.6, 2 significant digits. That's how many I'm going to give my answer. I'm only going to give it 2 significant figures. So if I plug this in the calculator and this is the number that I get, then I have to look. I only want 2 significant figures. So the 2 is significant, the 3 is significant, and I don't want to show any of the others as significant. So then I'm going to have to look at the number past the 3. It's a 5, so that's going to tell me to round up. So then I'm going to record 2400 as my answer. I do the same thing when I'm doing division. I just look at my numbers that are being divided together, and whichever one has the fewest, that's how many significant figures my answer will have. This is where we're going to stop as far as scientific measurement. There will be another video that goes over the metric system.